Hey, what's going on, guys? It's Mr. Sanchez coming at you with another video for this section in pre-calculus, section 5.4, the logarithmic functions. We don't have a warm-up. This is also the slides for my class. And yeah, we're going to begin. Today, we're going to be focusing on one of 2 out of 3 out of 5 learning topics. All right. We're going to be focusing today on changing exponential statements to logarithmic statements and logarithmic statements to exponential statements. And we will also be going over how to evaluate logarithmic expressions. If you look at the page numbers, those are the page numbers in which you can find examples for this in your book for pre-calc. Okay, but before we begin, we got some important information that I've already highlighted where the important details are. But imagine we got to go over what a log is, right? So imagine a one-to-one function where y equals f of x. All right, any one-to-one function has an inverse function that if y equals f of x, then f of x is going to be x is going to equal to f of y. That's going to be the inverse function. You swap where the x is with the y is. And let's look at it. In particularly, we want to look at an exponential function. So an exponential function is going to look like this: x equal. Oh, my bad. So if you look at y equals 5 to the x, then the inverse function is going to be x equals 5 to the y, right? What's so special about these inverse functions in math is that when you do the inverse of an exponential function, it gives you a special function called a logarithmic function, which is already highlighted. The definition, the logarithmic function with base a, where a is greater than 0 and a does not equal 1, is denoted by y equals log base a of x. That you read as log base a of x. That means if y equals log base a of x, it can only happen if and only if x equals to a to the power of y. The domain of the logarithmic function of y equals log base a of x is x greater than 0. Okay. And yeah, we're gonna go ahead and do some problems, but let's see what's going on next. All right. In words, basically, put simply, when you read log base a of x, think of yourself a raised to what power gives me x. Okay. And we're going to go ahead and do some examples right here. Okay. This is the first example. We're going to relate logarithms to exponents. Okay. And basically, if we look over here, it says y equals log base 3 of x. If this is equal to this, so if y equals log base 3 of x, then the inverse function is equal to this: x equals 3 to the power of y. Okay. And then what does that mean? So let's say 4 is equal to log base 3 of 81, right? That's the same thing as saying 81 is equal to the power of 3 to the 4, right? So when you have your base, so we're asking what power of 3 gives us the number of 81? That's going to be 4, right? So 3 to the power of 4 gives you that 81. That's what the logs tells us, okay? Similarly, if you look at example B, if y is equal to log base 5 of x, then x equals to 5 to the power of y. So if we have log base 5 of 1 over 5, we're thinking 5. So we have this one right here, right? We're negative 1 equals log base 5 of 5. So we're saying 5 to what power is equal to negative 1, right? And negative 1, right? And that's gonna be, no, my bad. I'm sorry. We're saying 5 to the power of negative 1 is equal to 1 over 5, right? So 5 to this power gives you this. Yeah, it's a little confusing, but the more you practice it, the easier it'll get. All right. Yeah, so let's go ahead and go on to the next slide. All right, this is where we have some actual problems. It says changing exponential statements to logarithmic statements. Change each exponential statement to an equivalent statement involving a logarithm, right? So this is hard at first, and I'm not gonna lie, it's a little tricky, but once you get the hang of it, it gets a little bit easier, all right? So we gotta use this fact. This is a fact, right? So if y equals log base a of x, then x is equal to log base a of y. All right. So right now, they gave us one, let's go with number one. 1.2 to the power of 3 is equal to m. Let's identify what this part is. All right, so this m here, that's gonna be x, right? This 3, this is y. So this is x, this is y, and this part is a, right? Now that we have all these parts labeled, we just gotta follow this formula, right? So y, what is y? That's 3. Log, that's just part of our problem. What's our a? A is 1.2. And then what's our x? Our x is m. So that's how you rewrite the first one. 3 equals log base 1.2 of m. All right. And I'm not gonna lie, it's kind of hard. It's hard to remember this at first, but the more you do it, the easier it gets. All right, let's go ahead and try number 2. It says e to the power of b is equal to 9. All right, let's label some things here. All right, we have e. E is our a. Okay, we'll write that down. E is our a. B is our y, and 9 is our x, right? So if we follow the formula, y is equal to b, right? So b is equal to log base e, right, of 9. Well, here's something special, actually. E, log base e, is actually written as ln for the natural log, okay? And that's how you get b is equal to ln of 9. All right, and let's try one more. And the more you do it, it's going to get easier. Okay, a to the power of 4 is equal to 24, right? Once again, our a here is actually a. Our 4 here is y, and our 24 here is x. So it's y, so 4 is equal to log base a, right, of x, which is 24. All right, so this is saying a to what to the power of 4 is equal to 24. All right, and that's the basics of it. All right, the more you do it, the easier it gets. So, we're gonna have some problems you can practice on your own later on in class. All right, let's go to base 3. All right, so each logarithmic statement to this time we're gonna go backwards. Instead of going from exponents to logs, we're gonna go from logs to exponents. So log to exponent, right? We have log base a of 4 equals 5. So this one is saying a to the power of 5 is equal to 4. So a to what? And then, so, right? So a is a, 5 is x, and 4 is y, right? But basically it's easier to go the other way. For me, it's easier to go this way. So it's right here, log base e of b equals -3. So we're saying e to the power of -3. So this to the power of this is equal to this, is equal to b. This one is going to be log base 3. So 3 to the power of c is going to give me 5. Okay. And that's basically it. That's the simple version of doing it. All right. All right. Example 4, finding the exact value of logs. All right. This is going to be a little bit interesting. All right. So this is saying log base 2 of 16. So this is equal to x. Okay. So this is saying, let's let this equal to x because we got to solve. So this is saying 2 to what power? 2 to the power of x is going to be equal to 16. Well, what do we know about 16? 16 is 4 to the power of 2, right? Well, what do we know for 4 to the power of 2? 4 to the power of 2 is 2 to the power of 2, and that's being raised to the power of 2. So 16 is really just 2 to the power of 4. We have the same base, so our exponents must be equal. So x equals 4. So log base 2 of 16 is 4, right? And we're going to do the same thing for problem B, all right? I'm going to let this equal to x, and then we're going to say 3 to the power of x is equal to 1 over 27. All right, and then we do some little transformations, okay? 3 to the power of x, 27 is the same thing. 1 over 27 is the same thing as 27 to the power of -1. And we know that 27 is 3 to the power of 3 to the -1. So we're going to say 3 to the x is equal to 3 to the -3. Therefore, that means x equals -3. So that means that log base 3 of 1 over 27 is equal to -3, right? That's the work behind it, okay? Any questions? No? All right, let's go on to our next slide. Our next slide is problems I want you guys to practice, all right? And if you need any help, feel free to let me know. Oops, we have some domain problems and we did not cover domain. So ignore this section. This is in the next video, okay? But other than that, have a great day, guys. Bye-bye.